We'll be talking today about middleware for beginner-friendly error messages that we're developing. That's called Babel. We come from faraway land of Minnesota and also faraway land of academia. I'm Elena Machkasova. I'm computer science faculty at the University of Minnesota Morris.
I'm Charlo Shaw, student at the University of Minnesota Morris.
I'm Ethan Uphoff.
I'm RJ Holman, senior at Morris.
So a little bit about the place that we're coming from. It's a liberal arts campus of University of Minnesota. It's undergraduate only. That's how I get to work with all of these wonderful students. We don't have grad students, so that's how it works. We are about 3 hours from Minneapolis, so we're in the middle of the prairie in a town of about 5,000 people. We have what many people would call a small computer science program. We graduate about 20 to 25 students per year. The interesting fact about UMM is that about 40% of our students are first generation to graduate from college. Also based on a little bit of surveys that I did in my introductory classes, about 60 to 70% of our students have not done any programming coming to UMM. And I'll let my co-presenters talk a little bit about their experience and what they started from at UMM.
So my first language was GameMaker language. I messed around with GameMaker Studio for a while. It's not really a good applied language, but it taught me a little bit about loops, variables, how to write if statements.
Before coming to Morris, all I had done was some very simple bash scripting.
All right, I'd be part of that 70%. So Racket was my first introduction into programming.
And I should mention that we have actually 2 alternative classes for beginner programmers, so students mostly with no programming experience. One of them uses Racket and uses how to design program curriculum, and the other one uses Python. Okay, so now that you can imagine what our target audience is for the things that we would like to do, let's think about beginner programmers and what they have to learn in their first 3 months of learning how to program. They need to learn to write programs according to some syntax rules, which would mean that they know where to put parentheses and how to put parentheses sometimes in a little different places for different functions or different macros. They need to learn how to read program code. One of the most important things that they need to learn is if you're given a problem, how do you translate that into programming terms? And that's one of the things that we emphasize in our introductory classes. They need to know how to test their programs to make sure that they do the right thing. They need to learn to write code that's understandable to others, and that always means that they themselves have to understand their code 2 hours after they have written it, which may be a challenge. They need to know how to debug programs. So if something went wrong, they need to know what went wrong and why, or how to figure out what went wrong and why. And in that process, they need to learn how to read error messages and how to fix errors. And another thing that we emphasize is that we always communicate about code with our students. Do a lot of pair programming, and also they write comments. So there is a lot of things that they need to do to communicate the intent of their code. And if you think of Clojure error messages in that context, so if you think about beginners, let me give you a couple of examples of code that beginners could potentially write. So this would be a perfectly reasonable thing to write if you're a beginner, because some things have quotation marks and some don't, and you don't know which ones should have quotation marks. And Clojure response was this. So that's probably not what you want for a beginner. And this is also a perfectly reasonable thing to write. It's a 5-character string, so you're taking its 5th character, right? And that's what you get in return. And that talks about index being out of range and character at, and none of this stuff is actually reasonable for a beginner. And if you happen to have a function called let, or if you think you have a function called let, you can pass it to map, and that's what you get back. So these are just some examples that could potentially happen if you are a beginner. And so this is what we have in our software. So this is what we're giving students instead, or potential students, and I'll talk about that later. So here, in function even, the first argument is expected to be a number, but a string 8, but is a string 8 instead, which actually gives a lot of important information, and among other things, doesn't remove those quotation marks that were removed in the first error message that you saw in the default error message. Position in a string is much easier to understand than index. And the last one, well, we kind of have to say something reasonable there. Again, that may not be perfect, but at least it's better than what the default is. There is some work in Clojure now that addresses some of these issues. I would like to mention a couple of projects here that work also on improving experience for programmers, and in particular could be helpful for some level of beginners. So Expound makes spec messages human readable. Maria.cloud is a very interesting project that is focusing specifically on beginners. And the last one is a tool for helping understanding stack traces. So that's also related. Okay, so where does this all fit? One most common myth about me is that I'm the person who teaches introductory class in Clojure, and I'm not, because it's not quite there yet. There is no setup that I can put 35 or 40 students into and have them have a successful learning experience going from complete beginners to actually future programmers. But I very much would like to do this. And some of the things that are missing there, we need to have a lot of materials that are ready to use so that you're not reinventing things or inventing things on the fly. And also, there needs to be a beginner-friendly setup, and part of that is error messages, part of that is IDE, help that's organized so that it can be easy to navigate by beginners. So lots of things need to happen. And this has been a 6-year project by now, so it's sort of embarrassingly long project. I will focus on error messages part of that project. So the first thing that we tried was using try-catch, because it's Java, right? So you surround your Clojure code with try-catch, and then you catch the error message, and you process it and throw it back. Part of the problem with that is that it's not immediately clear how to connect this to REPL. And I really would like to have REPL-driven development where you can try things and see how they work interactively. Also, lazy sequences, in that approach, we had to evaluate all of the lazy sequences, which prevents people from using things like infinite ranges, for example. So that's really not what we actually would like to do. But it helped us think about phrasing of some of the error messages. We did a usability study based on that very much imperfect system. And compared to default closure error messages, they're more helpful to beginners. Well, that's not unexpected. And then spec came out. So spec is the tool for the job that we were trying to do. We used asserts in the first approach. So we spent some time transitioning to spec. And then it became clear that what we really need is nREPL middleware, so that we can just plug it in the system. It's IDE independent, and it can just work. We will actually be talking about 2 versions of the project. It's very much work in progress, so there are a lot of things there that don't quite work the way we want them to work, and it may not work in all contexts. Version 1 is the one that we have on clojures, and that basically matches error messages as strings with regular expressions. Version 2 is in development, and that's catching the entire Java exception object with all of the data and then processing that, and we also have the ability to process stack traces. So Charlo gets credit for figuring out all of the middleware stuff, and Charlo will be continuing this presentation.
So in the default nREPL setup and in default closure, you're going to have star E, which is the most recently thrown exception. In nREPL, you're always programming at an nREPL client. You'll be typing code in, you send it, and it'll, if it's on the same computer it's still sent off to a server. Along the way, it's sent through a stack of middleware, which provides various helper functions and utilities, transformations to it. It reaches the nREPL server, which is part of the middleware, and that's where evaluation happens, where your code is actually put into effect. Then it gets sent back through a transport function, and it reaches back to you on the client, and you see the results. Now, in our system, we add a middleware to the stack. This middleware is going to take every single message and modify it so we can catch it on the way back. We have also added some specs for core functions and macros that we need to gain further information. And this one, again, we're emphasizing that's processing based on regular expressions. We also have built a number of tools to help us in the development of this. We have a tool that lets us generate spec info from metadata, and we also have a logging and testing tool which lets us compare across large amounts of error messages at once. The second version, we'll be going in more detail, don't worry. The second version actually looks up previous versions of star E in the actual namespace of nREPL and has most of the other features. Now, to break things down further, the REPL middleware stack, it starts at the server. Okay? And if you've ever used middleware like in Ring, it's fairly similar. You have a stack of functions which are all composed around each other. Unlike Ring, these are ordered by their metadata. They specify which operations need to come before you, which operations need to come after, and nREPL itself handles sorting out who's first. They pass around a hash map that includes all the information about your code and all the other information that's been added by other middleware. Now, because a piece of code can have multiple returns, you could have a print statement, you could be returning from another thread, you don't come back the same way. Every message inbound has a transport key, which includes a transport function that is called, that gets and is guaranteed to get messages back to the client for display. Which, because we want to be after evaluation, we wrap that function so that code checks back with us on its way back out to the client. So come in on the transport, hit the middleware stack, we get the you need to be checked in message, it's evaluated, it hits the interceptor, and then if we don't have anything to do with it, we pass it back. There was some highlighting I forgot. So unfortunately that means we have to touch every message, but we can quite quickly discard the ones that, well, not discard, pass through the ones that we don't need to modify. Now this is where the big difference between our present version and our in-development version are. In the present version, the error message has already been rendered down into a string, often even truncated from its two-string representation. We're able to process that using regexes, but it's not how we'd want to do it. In the improved version, when we receive the message, we just ignore the string and we look back into the actual definition of the nREPL namespace, into the present server, into that, and get the error directly from *E, where it has just been updated by Clojure itself. And then we pass that off to our parsing, and we get back a hopefully improved error message. Parsing itself is something which I'll leave Ethan to explain.
All right, so once we've gotten the error back from all of the middleware, we essentially have to send it to a printer. And the way that we're going to process all of these errors is we're going to take the error message in its class. And we first go through this massive vector of maps. And we first compare against that class. And once we've found the class, we can go through and we can do regular expression matching on the actual error message itself. So once we've done that, we have these capture groups that we have used in the regular expressions. And we're going to use that to build our new error message with this make message info object. So before processing, you might see something like Java lang string and Java lang number. And we're going to just change that entire error and rename those into a number and a string. This is just to make it easier for beginners because they might not know what Java lang string means or Java lang number. So we change that using a variety of functions on the side that we use after getting all these capture groups and all of that from the actual message. Okay, so another really important part of processing these actual error messages is using clojure.spec. So clojure.spec, of course, allows very customizable errors, essentially. So we have something like map33. Map33 is kind of returns a really bad error. You don't know how to create an iseq from Java lang long. So to a beginner, that means nothing. But then even after processing it, it's very uninformative. You're not going to get much out of that error as a beginner or even as somebody developing. So we go in and we've created spec errors for a variety of functions just to make it easier for beginners. So in this case, we've mapped spec out. So we've made a spec for map. So now we get in function map, the first argument is expected to be a function, but is number 3 instead. To a beginner looking at this error for the first time, that's going to be far more informative for them. Another really interesting thing, though, about being able to use specs is the customization that you can do with them. So in our case, we specifically want to look at the length. So even 3.3, even can only take one argument. So essentially, you're going to get an arity exception that says wrong number of arguments you pass to even can't take that, which it's pretty informative, but we want to go further with that. They don't know how actually long even needs to be, how many things can be passed to it. So a normal spec error, if we don't include length processing, is just going to include this extra input. That's all we can really get from it. So that's not really enough either, because that's even a little bit worse than the previous exception. That just tells us there was maybe more than the number of inputs needed, and you don't know how many you passed in. So then, as an alternative with spec, we can create these additional things for it to look for. So in this case, we created a thing called blength1. So blength1 looks at it and says, this function can only take one argument. And when we're processing the error message, we can actually look for that part of the string using regular expressions and get something out like this. Even can only take one argument but receive 2 arguments. That tells the beginner exactly the number of arguments that they need in their function, which is a bit better for them. So this is what our specs kind of look like in all of the specs that we've created. We will do the normal specking, but we'll also add in the length checking beforehand. So spec data processing is going to change quite drastically in the new development version. So we currently are parsing spec errors as strings, like every other type of error. But with *E, we can actually go in and we can get data out of the error for specs. So instead of having to parse the string, we can now get the function name from the cause like we do normally, but we can also go into that data and go into its map and go into the first one, that clojure.spec alpha problems. And from there, we can get out all of the data that we got out from that string. But now we don't have to individually parse every spec message, so we can put it into a template. So below, I have the processed error here. So that just says in function map, the first argument is expected to be a function, but it's a number 3 instead. That's the same sort of error that we were seeing before. But in those highlighted spots, that is where we have put it into a template. So this is actually from our in development version at the moment. All right, and I'll go into RJ for testing.
All right, so shifting gears here a little bit, I'm going to go over 3 things. I'm going to go over testing. I'm going to go over the what is it called? I'm going to go over the logging that accompanies the testing and a little bit of what I did this summer. So the testing works essentially with comparative testing. So it's expectations testing. So there's an error and a code snippet that accompanies that error. That code snippet goes through the nREPL server. It comes back through a regular expressions processing, and it comes and compares to see if those things match. Hopefully they do. But what's really interesting about these testings is what we do with them. So what we do is we actually record it, and that's our logging. And this was developed by Dexter at UMN Morris. So what this does is it gives us developers a lot of useful information, such as the code, the modified error, and the original error. So what's especially important here is the original closure error, so we can see what we got instead of having to open up a new terminal or something crazy like that. So this runs essentially every time the tests run. We get this updated, so you can have all this useful information. It comes with filtering tools, and you could see just the original errors if you wanted to. There's a few examples here. So we have a divide by 0 error, pretty typical, standard. And we have a defen, and this is a macro, and this is part of what I did this last summer. So we have an original error, which is, just look at that thing, and we have our modified error. So this is a lot of what I did. So let's go over how we did this. So there's a list of macros up here, and those are the ones in the project that have built-in spec errors. And my goal was to use the current implementation of the regular expressions. So I had to pick and choose the bits of information we wanted to use to make error messages out of that. And it was kind of difficult making good error messages for these things because you need to do sort of a balancing act between how specific you got to make it and how general purpose you want to make it. So it could be very difficult getting something useful out of this, but what was done is essentially laid the groundwork for version 2. And what version 2 is the Java object exception objects that were discussed earlier. So these, instead of using regular expressions, we can ask for certain pieces of the error message, which will help streamline things and make this a lot more straightforward and streamlined. Lastly, there is a little example here with defen again, and this time we forgot a vector, and there's a little error message about that. I'll hand it back to Ethan.
So we don't actually want to spec everything that we see that needs to be specced. So essentially, we created a process that generates specs from function metadata. This is kind of outside of Babel itself, but it points into our project still. So what we're doing with the spec generation is we're taking a function. So let's say on this diagram we have f, which can take n and a collection, and we'll say n is a number in this case. So what we do is we take the metadata, which is going to have an arguments list in it, and we're going to take that arguments list and we're essentially going to guess types from it. So in this case, n and call, we assume that that means number and collection. So we might also have a function that takes x. So we say that x means number or x means string. We can change this for whatever we're working with at the time. And essentially from there, we take this intermediate representation that we create from this guessing, and from there we can format it into an actual spec. Now, right now, the way that spec generation works is it ignores the intermediate representation. It just kind of doesn't show you it at all. It just skips over and immediately creates specs. But in a future version that we're working on right now, it will hopefully stop at the intermediate representation. So we're going to output that to a file where the user can go in and edit. Because we're guessing all of the types based off of this arguments list, we can't really be completely accurate. So we want to make sure that that accuracy is there. So at least giving the user the ability to go in and fix the various things that they see. So like one function may take numbers and call that X, but another function may take strings and call that X, and they might be in the same library. So we're going to have that issue, so the user can go in during that stage and change all of the, whichever one they've done, so like change numbers to strings, and then they can send it back into the code and run it as a spec generation. So also at the moment, it prints out to the command line. We're hoping to make it so it prints out to a file, which is completely set up for you to use, so that it can immediately be put into your project. And this is an idea that has been extended from a previous idea done by Sean Stockholm.
All right, so now on to some things that we would like to have, and now that we can get actual exception object, we can have stack traces. And we played with stack trace filtering earlier in our earlier versions when we would just catch an exception. But there is more work to be done there. So this is what someone would get if they have a function average and they accidentally pass total as 0, so they're dividing by 0. And notice that, well, first of all, we can't even put the whole thing on the screen because it's huge, and nothing there actually refers to the user code as far as we can see. So something like this would be much easier for beginners to see. And there are multiple tools for stack trace filtering, so the hope is that we can just plug in one of those, or can do our own, or perhaps think about even better way of representing a stack trace, so something along the lines of you call the function average from main, rather than giving things that look like Java. And then you heard that there is a lot of ongoing work for what we're doing. So our main goal is to actually have this version 2 that takes advantage of actual information about the arguments, information about the stack trace. And so we can do stack trace filtering with that. We can do line numbers. We can have better spec errors handling, especially for macros. Because, as you saw, these errors are completely incomprehensible. And if you just apply regular expressions to them, this is very, very difficult to get anything meaningful from them. So RJ did a fantastic job, but there's clearly, it would be much easier if we can actually access them as a map, all of the information there. We also plan to revisit the usability study, and at this point try to play with different wording for error messages. We're pretty much guessing on what would be helpful. And we can also look at common causes and provide additional information about what may have caused the error. We have to be very, very careful with that because based on just the error, it's difficult to guess what was meant. But maybe we can provide some information and just see what people, how people use Clojure as beginners and what mistakes they make. We also would like to do more of this semi-automated spec generation that Ethan mentioned, and in particular, what errors we give if the length is wrong, so wrong number of arguments. And we also would like to try this for different libraries, so something like Quill might be a good candidate for that. Our logging, as it was pointed out, would be much better done with agents rather than throwing everything into an atom, so that's another item on the list. And then it would be great to try to incorporate this with IDEs and other tools. And also, of course, there is Clojure 1.10, which sounds really exciting in possibilities that it opens. We don't know yet what it might be, but certainly something that we should look into. And I would like to thank numerous students who participated in this project. These are just people who work on error messages. So Dexter is a current student, and Sean Stockholm, sitting over there, now works at Roomkey, a recent graduate. As you see, there have been multiple people who worked on that. We would like to thank ClojureConf organizers for helping us all to get here. And also various funding that supported these wonderful students. And also all of the feedback and help that we got from Clojure communities in Boston and in Minnesota, and various help that we got on Slack. That was all very helpful. And with that, this is where you can find us, and we still have time for questions.